Okay, we're recording now. Real quick primer on random numbers in C++. Now, I've gotten a number of comments from students that they were taught to use the random preprocessor directive and then to use a number of somewhat complex functions. And you can certainly do that, but that's it. I think if and only if you want finer, more granular control over what type of random numbers are being generated. Now, normally when we ask for random numbers, if we can think back, I'm sharing my iPad now, if we think back to high school and previous math experiences, just about distributions. Now, here's a normal distribution, and that's the typical bell-shaped curve, where most of the data values are in this area here. Here's the average, here's the first standard deviation, and then the second, et cetera. And then here's what's called a uniform distribution, where there's the same amount of numbers evenly distributed across the number line. Now, C++ native random functions just beautifully deal with uniform distribution, and all of our random numbers that we're going to want are just going to be random or uniform distribution. So this one here, and we're not necessarily going to worry about getting random numbers from a normal distribution. All right, so that's what we're going to go for today. And because of that, we don't need any preprocessor directives or anything to get random numbers. What we'll do is use the out-of-the-box, and this is right in the book too. I'll check out what chapter that is, I forget, for random numbers, 3 or 5 or one of those. But to do random numbers using C++ native functions, first, it's always going to be best to go ahead and create a couple of constant integers, one called max and one called min. Let's say this one's going to be 100 and min would be 70. And what this will do, our goal here is to create a random number between 70 and 100 inclusive. Now, the formula right out of the book is simply this. Rando's my variable name, and it's going to get assigned then whatever gets returned here. So we go ahead and we call the rand function here, and then we go ahead and mod it by this formula here, max minus min plus 1 plus min. So this is the formula that will always work, that's going to give you random numbers between min and max that are inclusive of min and max. That's important also. You could get a 100 out of this code, or you could get a 70 out of this code just as easily. So remember that little feature of this. So given this function, and this is one of those functions, I swear students, take me up on this. You'll want to get this tattooed on your forearm because we'll be coming back and back and back to these types of formulas left and right. So that's a good one to just flat out memorize. Now let's then go to my IDE and put this into practice now. Oops. Come on, IDE. Oh, it logged me out. Let me jump back in here. Any second now. Hey, what'd you do in college today? Well, I watched the professor just nod his head back and forth while I waited for his IDE to boot up. Hey, here it is. All right. So this code here is going to do the trick for us. So I said before 100 and then a 70. And what I'm going to do here now is just run this a number of times, and you'll see that the output we get is very well behaved. And then here is the random number formula that we've all memorized at this point. And all I'm going to do is assign that to a variable called size and then simply run that. So you see here, I'm going to do a bunch of runs and we'll get numbers between 70 and 100. It looks like it's well behaved. I've got a 78, an 89, a 92. So that's looking good. That's looking real good. So the other thing to remember when we deal with random numbers in C++ is that the random number formula, it's just a formula. It's a very long one. It's got some very complex data structures in it. But nonetheless, it's a formula. And it needs what's called a seed value. Otherwise, the random number is going to be the same every time you run it. So if we inject a seed value that's unique every time we run the program, then we'll get random results. And this is the common problem in computer science, that there truly are no random numbers, but we can get very close to approximating random numbers if and only if we have that seed value. So this statement here in line 8 of the code, sran times 0, that is going to tell our compiler to use the system clock to generate a seed value. And the system clock, of course, has a different value. Every millisecond, it's got a different value that it can offer up to the compiler. So sran times 0 there is what's going to be the trick for using the system clock for our seed value. If we were to comment this out and then run the program again, you'll see that we're going to always get 80 every time we run it. There's another 80. There's another 80. There's another 80. Hey, what'd you do in college today, kids? Well, I watched the professor run this program over and over and I got 80. That's what's going to happen if you don't use the system clock for the seed value. So those two things. The other thing to remember is every time you type this function call, rand, it's going to generate a random number. So if you've got that kind of buried in your code somewhere and you're wondering, why am I getting these extraneous random values generated? Well, it's because you probably got a second or a third call to rand in there, and that it might be unnecessary. All right, we can easily do this inside of a loop. Let's try this now, where instead of counting a variable that we have created that's random, let's just go and do a let's do, how about 25 random numbers? And what this is going to do then is give us 25 random numbers. I'll put an n line there. Let me get my indentation correct. And there it is. Well, it's almost correct. And then I can run this and we'll get a list there of 25 random numbers. And you see that these are well behaved between 70 and 100, okay? You can, if we were to say have another random number like this, so there we're creating iterations. Now, iterations here, it's in a format that's simply ran mod 20. And we've got to remember that if we do this format, we can do it very easily. And it's going to give us random numbers between 0 and n minus 1. So we'll get random numbers between 0 and 19 in this case. And what we can do is provide an offset if we wanted, say, to get numbers between 1 and 20, well, we could just provide an offset of 1. So now this is going to give us a random number of iterations. And then that for loop is going to go through the for loop, that number of random iterations. And every time in the for loop, it's going to crank out a separate random number between 70 and 100. So let's run this now and we'll see, okay, iterations was randomly set at 6 this time, and there's the numbers that it cranked out. So these are the ways that you can kind of mix and match our coding tools to just get whatever task we need to get done. This is the key here. We could certainly substitute this in. Let's try that. And get rid of this variable here. And then this will do the same thing. It's just going to save us a little bit of memory because we don't have to carve off a chunk of memory that's going to store that number iterations. Here, as soon as that for loop enters, it's going to go and give us the random number. So that's the quick primer on random numbers, and I will start the next one here in just a few seconds. So I'm going to stop this one now.